I'm going to do a hypothesis test for two proportions from the homework. This one says, let's see, in a tennis tournament, for men, 425 of 1422 calls were reversed. For women, 226 of 774 were reversed. And with 0.05 significance, test the claim that men and women have equal success in challenging calls, so the two proportions are equal, is what this question is asking. So when I go to the setup chart, now this is again written in terms of P for one proportion, but the claim is about proportions being equal. And so I'm going to this fifth row where it says P equals, that's how I'm going to set it up. Now I'm going to let P1 represent the men's proportion and P2 represent the women's proportion. So P1 equals P2 is the claim. The opposite is that P1 is not equal to P2. So the null hypothesis is P1 equals P2, and this is from the original claim. And the alternate hypothesis is that P1 is not equal to P2, and that makes for a two-tailed test. Now, in the first part of this question, this is the row that I'm using on this chart. In the first part of this question, they probably ask you to say what the null and alternate hypothesis is. Let's see, so the null is that they're equal, the alternate is that they're not equal. Which one of these says that? It looks like it's part C that says P1 equals P2, and H1 is P1 is not equal to P2. So I'm clicking on that one. Then identify the test statistic and the p-value. Well, that stuff we're going to have to use the calculator for. So on the calculator, I'm going to go to Stat, Tests, and for this one, I'm going to 2-prop z-test. So there's 2-prop z-test. And when I go there, x1 and n1 are the sample data from the first proportion, which was the men's calls. Now for the men's, it said 425 of 1422. So x1 is 425, x2 is 1422, and x2 and n2 are the data from the women's calls that were overturned. It said 226 of 774. So the x2 is 226, and the n2 is 774. Now the next line is supposed to match the form of the alternate hypothesis, and the alternate hypothesis for this one is a two-tailed test that they're not equal. So it's this first one here. So I'm going to make sure the cursor is on that one and hit enter. Okay, so notice now just that one is flashing. The color has to do with if you draw a graph. We're not going to draw a graph, so we're just going to calculate. So when I go down to calculate, I get the z there is the test statistic, which is 0.33751. That's something they asked for in the homework. And the other thing they're going to ask for is this p-value, 0.7357, 0.7357, the p-value. And so those are the two numbers that the homework is going to ask for. Of course, the P1 and the P2, this is the first sample proportion. P2 is the second sample proportion. Anyway, when I go back to the homework question, see this test statistic that was the 0.337, how many, they want 3 decimal places? 0.338 to 2 decimal places for the test statistic. That's about 0.34. 0.34, and then the p-value, they want 3 places, that's 0.736. 0.736. Okay, now we want to draw the conclusion. Note the p-value is greater than alpha, 0.05. So we're going to fail to reject the null hypothesis, and the null hypothesis was from the original claim. Fail to reject from the original claim. So when I go to look at the conclusion chart, I'm going to look at the fail to reject from the original claim, and this one says fail to reject from the original claim. There is not sufficient evidence to reject the claim. That's the conclusion. Let's see which one in the homework draws that conclusion. We're going to fail to reject. There's not sufficient evidence to reject the original claim. The p-value is greater than the significance. So fail to reject the null hypothesis. There is not sufficient evidence to warrant rejection of the claim. And when we check the answer, I'll cross my fingers. Fantastic.